Okay, so we have another induction question, and this time it's on summation. So, prove by mathematical induction that for all positive integers n, the sum from r equals 1 to n of 5r to the 4 plus r squared is equal to a half n squared times n plus 1 squared times 2n plus 1. Okay, it looks complicated, but really summation is also very easy, just like matrices. So number one, we have the base case, as usual, right? Base case. And again, we have all positive integers n. That means our base case is n equals 1. Let me underline that better. Our base case is going to be n equals 1 because that's the smallest positive integer. So base case is when n equals 1. When n equals 1, we have the sum from r equals 1 to 1. So that's just 1. So we have 5, 1 to the 4 plus 1 squared, which is equal to 6. And over here we have a half 1 squared times 1 plus 1 squared times 2 times 1 plus 1, which is equal to 1 over 2, and then we have 4, and then we have 3, and this is equal to 6. So now we can see this is true for the base case, right? So true for base case, because the left hand side and the right hand side both match up. When you put n equals 1, you get 6 on the left hand side and you get 6 on the right hand side, so that works. That's true. Now assume true for some n equals k. Of course, this is the same step as we always have for induction. Assume true for n equals k. So what does that mean? That means that the sum from r equals 1 to k now of 5r to the 4 plus r squared is going to be given by, instead of n, we have a k. So we have k squared, k plus 1 squared, 2k plus 1. Then remember, this is divided by 2. So this whole thing is divided by 2. Okay. Now we have to show, this is the difficult part, right? Well, not really difficult, but this is what takes the work. So show true for n equals k plus 1. So how would you do this? Okay, so now, with summation, you have to remember. So what I'm trying to find is the sum from r equals 1 to k plus 1 of 5r to the 4 plus r squared. But this is the same as taking the sum from r equals 1 to k of 5r to the 4 plus r squared, and then doing the k plus 1th term instead of r. So this is that plus, and then I have 5 k plus 1 to the power 4 plus k plus 1 squared. This is exactly the same thing as this right here, because you're doing sum from 1 to k, and then you're just doing the k plus 1th term, so you just put k plus 1 instead of r inside, and you'd end up getting this. Okay. And we know what this is, right? We already have this given to us. That's this right here. So now this is equal to k squared, k plus 1 squared, 2k plus 1 divided by 2, plus, and now we have these things right here, whatever all this is. So we have plus 5 k plus 1 to the power 4 plus k plus 1 squared. Okay. We can see, we can take out k plus 1 squared over 2 as a factor, okay? Because as you see, we have k plus 1 squared here, we have k plus 1 to the power 4, and we have k plus 1 squared. So we can at least take out k plus 1 squared. And I'm going to bring out the half as well, because why not, right? So I'm going to bring out k plus 1 squared over 2. And now I have k squared, 2k plus 1, plus, now this becomes 10, because I took out a 2, I took out a half, so now I have to multiply this by 2, so it becomes 10. And now I just have k plus 1 squared, plus, and now I have a 2, and then k plus 1 squared came out here, so that's it, plus 2. Okay, now what do I get? So I get k plus 1 squared, and there's a lot of algebra, so you just have to be careful that you're following along with the algebra. So I have k plus 1 squared over 2, and now over here I have 2k cubed plus k squared plus 10, and now over here I have k squared plus 2k plus 1 plus 2. Okay, so far so good. We just have to do a lot of algebra and manipulation. Now what do I have? I have the k plus 1 squared over 2 outside again. And we want this, right? Because remember, at the end of the day, wherever there's an n, we want to see a k plus 1. So we just have to show that this is true. So far, we have a k plus 1 squared over 2 outside. So we're going to leave that however it is. So we're not going to change this anytime soon. We're never going to change this, actually. And now we expand inside. So I have 2k cubed plus k squared plus 10k squared. And see, this is the thing about induction, because like you already know what you're gonna get at the end of the day, right? Like you already know that you want to end up having a k plus 1 wherever there's an n inside the original formula. So you literally know what you're gonna get. You just have to like get there and show that you're actually getting there. So I've just expanded the brackets here. I have 2k cubed plus k squared plus 10k squared plus 20k plus 10 plus 2. Okay, so what is this? So this is k plus 1 squared over 2. And now inside I have 2k cubed plus 11k squared plus 20k plus 12. Okay, now this is gonna be hard to factorize. Let's think of some factors I can do. I wanna think of 2k should be one of the factors for sure, right? So I'm gonna have k plus 1 squared over 2. And I'm running out of space, but I think it'll be good. So I have 2k, and if I have a 2k, then I'm gonna have a k squared here. Let's do a 3 and a 4. Would that work? So if I have 3k squared plus 4k. So now I'm just trying to factorize. I'm trying to think of a way to factorize to end up getting this. So I have 2k cubed plus 3k squared plus 8k squared. That's 11k squared. Then I need to get 20k. So I have 12k, and then I need to get 20k, and then I add a 4. Oh, that works out. That works out perfectly. So I have 2k cubed plus 3k squared plus 8k squared plus 12k plus 8k plus 12. And this can actually be factorized again. So now I have k plus 1 squared over, I'm really running out of space, k plus 1 squared over 2. And now I have 2k plus 1, so this becomes 2k plus 2 plus 1, right? And now here I have k plus 2 squared, because k squared plus 4k plus 4 is k plus 2 squared. But this is actually k plus 1 squared. So I actually have k plus 1 squared over 2. And now over here I have 2k plus 1 multiplied by brackets k plus 1 all squared. And look, that's exactly what we wanted to show. So let's look at the first n. We had an n over here, and instead of an n, we end up getting k plus 1. So that's good. And then over here we had n right here. Instead of we have n plus 1 squared, and instead of an n, we have k plus 1 squared. And then over here, instead of a 2n plus 1, we have a 2k plus 1. So you can see that it's true for n equals k plus 1. So I don't know where to write the conclusion, so I'll just write it over here. I'll just write it down here. So true for n equals k plus 1. Because remember, at the end of the day, all you're trying to show is that wherever there is an n, I actually want to see a k plus 1 with the formula that we're given. So it's true for n equals k plus 1. Therefore, this means therefore, by induction, this is true for all positive integers n. And honestly, the only tricky part, there are only two tricky things about this whole question that I saw so far. So understanding that k plus sum from 1 to k plus 1 is the sum from 1 to k plus the k plus 1th term. That's the first important thing they need to realize. So this is like the first important thing. And then the second important part perhaps was just understanding that you can factorize this like this. So like this is the other, I guess, tricky part. Like knowing you can factorize it in this form right here. And then the third, I guess, tricky part would be just getting into the final form. But that's always going to happen. That's not even tricky. You just have to manipulate it in a way that you can get to the final form. But this here, if you don't see the factorization, then it can be very difficult to do this question. But as soon as you see the factorization, and guess what? You can literally think about this and just factorize it like this and see if it works. But just show you're working out like how we did and you'll be good. So yeah, hope you enjoyed the video. Hope it made sense to you. If it didn't, let me know how else I can explain it to you. And yeah, if you liked the video, then like, share, comment, subscribe, and let me know what else you want to see in future videos in the comments. Thank you for watching.